multiplication of exponential expressions. And we will also have some with variable bases. So let's talk about exponents. So here's my base, and here's my exponent. And my exponent tells me how many times the base is multiplied by itself. So in this case, 3 times 3. Okay? But what happens if I have something like this? 3 squared times 3 cubed. Well, if we deconstructed these, it would be 3 times 3 times, and then 3 cubed would be 3 times 3 times 3. So it would equal 3 to the 1, 2, 3, 4, 5th power. So what we can see from this is that when we have the same base with some exponents, what we can do is simply add our exponents. 3 to the 2 plus 3 equals 3 to the 5th power. So we can add our exponents when we multiply. And we've talked about this before, actually, with when we were doing some scientific notation problems. So this really should not be anything new to you. So let's do some of the examples we have in your notes. So the first example is 5 squared times 5 cubed times 5 to the 4th power. Since our bases are the same, we can simply add our exponents. So it would be 5 to the 2 plus 3 plus 4, which equals 5 to the 9th power. And in this case, we don't have to work out 5 to the 9th power, but if it's simple enough, then we should just work it out. So I'm going to let you do the 10 to the 15th power times 10 to the 17th power on your own. But let's look at this one, 5 squared times 2 to the 3rd power. In this case, because our bases are different, we can't just add our exponents. So we would have to work it out as 25 times 8. I know that 25 times 4 is 100, so it makes sense that 25 times 8 would equal 200. Okay, so that's one of the key things, is that in order to add exponents, your bases have to be the same. So here we couldn't have done that. Let's look at the last one on the top. It's using variables. And so when we look at ones like this, we have to make sure we're only adding the exponents that have the same base. Here we have x's and y's. Y to the 17, x to the 4th, y to the 6th. Okay, these are all being multiplied together. So we can actually add exponents for like bases. So I'm going to circle my x's, and I'm going to underline my y's. So it equals x to the, 4 plus 2 plus 1, so 7. Y to the 17 plus 6 is 23. All right, I'm going to let you guys do the rest of those on your own, and we'll go over them in our weekly meeting. Lesson 102 is about adding like terms, which we've already done. So it's just going to probably be a little bit more complex because it's part 2. So looking at my first practice problem, we have 4x plus 3 plus 6x plus 4 plus 2xy plus 3yx plus 2. So now let's circle our x terms. 4 times x, 6 times x. Our 2xy and 3yx are not x terms because they're also being multiplied by y. Let's underline our constants. We'll use blue to underline our constants. Okay, we have a 4, a 3, and a 2. And then let's talk about 2xy and 3yx. If you'll recall, multiplication is commutative. So just because these are not written in the same order doesn't mean they're not like terms. They actually are like terms because you could change the x and the y here and write it as 3xy. Okay, they've just written it that way in order to be a little bit tricky to make you apply the knowledge you have about the commutative property to this problem. So those two terms are like terms. So I'm going to draw boxes around them in yellow. So when we combine our like terms, we end up with 10x because we're adding the coefficients that are on the x, plus, and I'm going to go ahead and do my boxes next, and that will be 5xy. I could have said 5yx if I wanted to, but I wanted to say 5xy. And then add our constants. 3 plus 4 is 7, plus 2 is 9. And that is our answer for that practice problem. Let's do another one. 4 plus 3x squared plus 2xx, it's kind of weird looking, plus 4x plus 7 plus 3x. Now, first thing you want to do is try to understand what this xx is. What is x times x? Well, it's x squared, isn't it? So I'm going to cross that out and replace it with an x squared. So I'm going to circle my squared, my x squared terms, and I'm going to put a box around my x's, including the sign, remember that. And then I think I'll underline my constants. Okay, so the coefficients on my x squared are 3 and 2, and 3 plus 2 is 5. So 5 times x squared plus the coefficients on my x's are 4 and 3, and that 4 plus 3 is 7, 7x. And then my constants are 7 and 11, and 7 plus 11. I'm sorry, 7 plus 4. 7 plus 4 is 11. Okay, there's only 2 more of these practice problems left. I'm going to leave those for y'all to practice on your own. And let's go ahead and move into 103. Lesson 103 is the distributive, using the distributive property. So if you look at what I have in my notes, I said that 4 times 23 can be calculated by saying 4 times 20 plus 4 times 3. Okay, well, we could have written 23 like this, 4 times 20 plus 3. And here we can distribute our 4 across the addition. And you can see it better. 4 times 20 plus 4 times 3. This is the distributive property. Okay? So what if we have 3 terms in parentheses, like our very first practice problem there? 4 times x plus 2y minus 8 is equal to, you're going to multiply 4 by each term. Okay, 4x plus 8y minus 32. Okay, and why is it minus? Because this negative sign right here goes with that 8. It's attached to the 8. So it's 4 times negative 8, which is negative 32. Let's do another one of those. What if we needed to distribute a 3x? Y minus 2 plus 2x. Okay. We're going to distribute 3x to each term. So we get 3xy minus 6x, because that's negative 2, plus 6, 3 times 3 is 6, and x times x is x squared. So there's our answer for that one. Okay, there's 3 more for y'all to do on your own. And our last lesson for this week, lesson 104, is about classifying triangles and angles in a triangle. So if we classify triangles by their angles, what are the names for them? Well, if you have, say, a right angle in your triangle, what kind of a triangle is that? It's a right triangle. If you have one angle that has an obtuse angle, then it's an obtuse triangle. And if all of your angles are small little angles, it's an acute triangle. Okay, this is review. We've already gone over this. And if we classify triangles according to their sides, they are either equilateral. Okay, remember an equilateral triangle, all sides are equal. Isosceles triangles are such that 2 are the same and 1 is different. And lastly, scalene, where we have all 3 sides are different. Okay, so equal sides can tell us something about the angles. So let's look at our isosceles triangle. If you have 2 sides that are equal, that means that you also have 2 angles that are equal. So the angle opposite that side is going to be equal. So those 2 angles are equal. So if 2 angles are congruent, so let's say we had a triangle, and it showed us that this angle was 60 degrees and this angle was 60 degrees. I guess this would be an equilateral triangle if that was the case, because this one would have to be 60 as well. But what it tells us is that because those are both 60, this side is equal to that side. So let's just say we had something more like this. And this said it was 30. And this said it was 30. And let's say that you knew that this side was 6 centimeters. How long would this side have to be? It would also have to be 6 centimeters. Okay, because the angles are the same, their opposite sides are also congruent. And we also know that the sum of angles in a triangle, they always add up to 180 degrees, right? So look at that very first example. It says find the measure of angle BCA. So I'm going to do my best to copy said triangle. All right, we know that this angle here is 60 degrees. We know that this angle is 40 degrees. Okay, this is B, this is C, this is A. So angle BCA. Well, how do we figure it out? Well, we know that those two angles added up equals 100 degrees, and that all three together is 180. So we can simply say 180 degrees minus 100 degrees equals 80 degrees. Let's look at the third example. It says angle B measures 110 degrees. So it's an obtuse triangle, right? Because it's one of them is more than 90, one of the angles. That's angle B. These have marks on them that says, okay, well, these two sides are the same. They are congruent, same size. So if so at this point, how can we figure out the measure of angle A and the measure of angle C? Well, we know that all of the angles added up together equal 180. So if we subtract 110 from that, we get 70. So we know that angle A and angle C add up to 70 degrees. We also know that angle A is congruent to angle C. So if we divide 70 by 2, that is the measure of each angle, 35 degrees. Okay, I'm going to let you guys finish the rest of this.